This lesson is 5.3. This is lesson 5.3. Whoops. We're going to call this changing forms. In this lesson, there's not a lot of math involved. I have to teach you how to do this skill so that you can do what's coming up with actual math stuff, okay? So we have this thing called a logarithm, which we haven't seen yet. And a logarithm is the inverse of an exponential form. So we learned yesterday, we have something, and I don't like the letters that they used here. So we're going to rewrite this, okay? Make this x, and make this y. If you need to scribble it out, you can. Log base b of x equals y. And the only reason, it's going to be the same thing, whatever letters that you use, whatever variables you use. But I have taught with x and y for the last 6 years, so I am afraid that I'll make a mistake in my verbiage when I'm talking to you, and then you'll be confused. So let's just leave it as xy, okay? So if you see something in the log form, log is just the abbreviation of a logarithmic, okay? So we're going to change these into b to the y equals x. So these forms are kind of inverses of each other. We talked about inverses a couple terms ago, or no, weeks ago, not terms ago, a couple weeks ago. We talked about inverses, and so we're going to be using logarithm and exponential form in all of the problems that we're doing, okay? If you notice, in your calculator, you have a log button. You guys see the log button on your calculator? Your log button is always programmed to be base 10. So, in your calculator, if you're ever going to use that button, your problem needs to be base 10, because that's the way that your calculator is programmed. Not all the time is it going to be that, though, so we're going to talk about how to get something into log base 10 if we need to use our calculator for it, okay? Base 10. So you guys see here this log has a base, right? There's a little tiny little number there. This is at what we call a subscript. So this b value is a subscript. It's instead of an exponent that goes high, it's a subscript that goes low, okay? And that represents the base of something. And we'll talk more about what that is in just a minute. You can see here in example 1, this is a base of 3. You guys see that? This one is a base of 6. And we'll talk about what that means. But your calculator is programmed to be base of 10. So you cannot use your calculator unless your problem says log base 10. And so when your problem doesn't say log base 10, we have to figure out a different way to do it. All right, so I'm going to show you how to do that. What'd you say?
But if there's no base, it automatically is 10.
Yes, correct. So like,
can you still use, if there's no base, can you still use your calculator?
Right. If there is no base shown, if it just says log and there's no base, you can always assume that it's a 10. Just like, guys, when you write x plus 5, what do we always know is in front of that 1? In front of that x. A 1, right? And like if I say the square root of 5, what number is always right here? 2, right? Square root. So these are some things in math that you just know are to be true. So again, that log, if you don't see a base, you always will know it's a 10, unless it says otherwise.
So this would be what
So there are going to be times when you're going to need to move from log form into exponential form, okay? The best way to do this is to label b, x, and y. Okay, so if I'm looking at this problem, I know that this is my b down here, this is my x, this is my y, and I know that because it's coming from my equation up here, right, where the b was, the x was, and the y is. Okay, and then I'm going to write it in b to the y equals x form. So what letter did I use for, or what number did I use for b? 3. What number did I use for y? 2. And then my x value is 9. So we're just changing the way that it looks. We're changing it from log form into exponential form. Now look at this exponential form though. Isn't 3 to the second power equal to 9? It is, right? So it should come out to make sense. There's no solving here. We're just rewriting it. Okay? So let's look at number 2. Again, if I were you, I would start by labeling the things correctly. This is my b, this is my x, this is my y. I'm going to label them correctly. Then I like to write out what my formula is, so I make sure to put them in the right spot. So I have 6 to the third equals 216. And if you check on your calculator, 6 to the third is 216. Okay? If you had something like this, guys, 6 to the 216 equals 3, does that make any sense?
No.
Okay? So think about it as you're writing it. Like, this does not make sense at all. So I must have written it wrong. All right? So use some common sense as you're going through this. All right, why don't you try number 3 and 4 on your own? Who'd like to give their answer for 3? Crystal?
7 to the 0 power equals 1.
Okay, 7 to the 0 power equals 1. Guys, do you remember the rule about 0 exponent? Anything you raise to the 0 power is always going to be the number 1. If you raise 1,000,000 to the 0 power, you get 1. If you raise x to the 0 power, you still get the number 1. Okay? Tavy, were you confused on that one? Did you put them in the wrong order?
So it's going to be...
Here's your b. Here's your x.
Oh, yeah,
Here's your... Oh, you have it in the right form? Yeah.
Yeah, I put 7 equals 1 because I thought 0 would just...
Nope, you'll need it there. So that because if you were to go back to log form, right, if you were to go back into this form, you would need that exponent there. Okay? What about number 4? Who wants to offer their answer for number 4? Dalton?
2 to the 4th power equals 16.
2 to the 4th power equals 16. I would agree with that. That makes sense. Okay? What about when you have a fraction? Now, I told you yesterday we flipped the fraction, right? We changed it to the -1. But today, we're just rewriting. We're not solving anything. So we leave it as is. Okay, so we're going to leave our fraction as is. We're not trying to solve it. We're just rewriting it. All right, so on number 5, here's my b, my x, and my y. If I do 4 to the -2 power equals 1 over 16. Now let's talk about that. If I were to solve this out and double check that this is true, anything raised to the negative power means I'm flipping it upside down, right? We flip them. And what is 4 squared?
16.
So this is becoming 1 over 16, which is exactly what I have here. Okay, so again, this would be our answer right up here. Oops. But you can check to say, okay, if I raise something to the negative power, I am getting a fraction. Try number 6. Aspen, what'd you get on number 6?
9 raised to 3 over 2 equals 27.
Perfect. 9 to the raised to the 3 over 2 power equals 27. Please make your 3 over 2 look like an exponent. All right? Now, let's check that in our calculator. You all have a calculator. I want you to do 9 raised to, and then in parentheses, 3 divided by 2, close your parenthesis.
I didn't know a fraction could actually be an official exponent.
You can. Yep. Welcome to Algebra 2.
27.
Okay, you're getting 27, right? 9 raised to the 3 over 2. If you put the 3 over 2 in parentheses, you get 27. Okay, so that's a way to check as well. All right, the second part is going the opposite way. All right, so now we're going from exponential form into log form. So we're just writing it backwards. Okay, so if you need to, again, write your formula down here. We're moving from b to the y equals x. And I'm moving it into log base b of x equals y. Guys, please note that your b value needs to be little. Okay, your b value needs to be little. Your x and y are not exponents. All right, they are the same size as the word log, and they are on the same line as the word log. So if I'm looking at number 7, b, y, x. So when I move it into log base b of x equals y form, log, what's my base? 14. So I have a little 14. My x value is 196. And then my y value is 2. So if you label it correctly, you should have no problem putting it in the right spot. You do not need to memorize these formulas. They will be given to you. Okay? Anybody have questions with number 7, how I got them to where they go? You label everything as is, b to the y equals x. When you write your formula down, you just plug them in. Now I do want to tell you this. Look up here for just a second. Sometimes I have students do this. Log 14, 196 equals 2. You see that 196 looks like an exponent? It's not an exponent. And I have students do that every term. That's incorrect. 196 is the same size as the word log on the same line. 2 is the same size as 196, all on the same line. The only thing that's different is the base, which should be a subscript. Okay? So if you count it as an exponent, write it as an exponent, or I can't tell the difference, you'll lose points on it. Okay? All right, let's try number 8. So again, I would start by labeling b to the y equals x. Write my formula. My b value here is 3. 81 equals 4.
It's kind of hard writing and converting to log form than it is exponential.
Just following a formula. Guys, does it make sense? Look up here. 3 to the 4th power gives you 81. Right? That's a way that you can check it that you did it right. So again, I said 3 to the 4th power gives you 81. Okay, so you can kind of do a mental check that way. Okay, let's do number 11 and 12. Try 11 and 12 on your own, and we'll see if we get the same thing. Samantha, what'd you get on number 11?
I did number 9.
Oh, okay. Do number 11 for me. What did you get?
Log with the base of 2.
Okay.
Negative 3 equals 1/8.
Okay. So remember our formula says log base b of x equals y. And our x value is 1/8. Because if you said this, okay, if you said this, then what you're saying is 2 raised to the 1/8 power is negative 3. Does that make sense? Okay. So if we try it again, we get log base 2, and then what's your x value?
1/8.
Good. 1/8. There you go. Good. Okay, who wants to try number 12? Someone that I haven't heard from today. Donald. Help us out with number 12. Log base 8.
Log base of 8 equals 4
What?
over 3.
What's the number that goes right here next to it? Log base 8 of what?
Log base 8 of 16.
Okay. Equals.
4 over 3.
Perfect. Good. You guys okay with this? Okay. So let's move to the next page. So we talked about this a little bit already. A logarithm with base 10 is called a common logarithm and can be written out without a base. So we said if we know that it's base 10, then it can be written as just log of x. Okay. If it's a base 10, they probably won't write base 10. They might just write log of x. All right. So it says, use your knowledge of exponents to evaluate the following logarithms. We have log base 7 of 49. Now, I said again, you can't use your calculator at this point, right? Because it's not base 10. So we have to make this problem something that we can work on. So the first step when we're doing these, we're going to put our steps out here to the side, is we're going to set the problem equal to y. Okay, so on 13, we're going to set this equal to y. Step number 2, we're going to change this form into exponential form. And let's just go ahead and write what exponential form is. So if I am labeling this with my exponential form, remember this is our b to the x, and this is our y. And I want to change it to b to the y equals x. So when I change this one, it's going to be 7 to the y power equals 49. Are you guys okay with that? So we have log form, and I'm changing from log form into exponential form. It's just what we worked on the other side of the page. Does anybody know what I do now? Obviously, we know the answer is 2, right? But how do we show our work for this, Leanna?
I don't know, I raised my hand too fast.
Okay, think about what we did yesterday. What was our whole goal yesterday? What did we do with our bases yesterday?
We canceled them out.
We canceled them out, but we only canceled them out if they were what? The same. Okay, so step 3 is to get like bases, just like we did all day yesterday. So can I make 49 become a base of 7? I can, right? It's what? 7 squared. So I have 7 to the y equals 7 squared. And now what are you allowed to do? Cancel your bases, right? And then I just have y equals 2. Now again, from this point right here, we could have decided, hey, I know that it's 2, but we have to show our work because it's not always going to be easy like that, right? Let's try number 14. See what you can do on number 14. Follow your steps. See what you can do on 14. Press pause and try number 14, please. 27 can become a base of 3. Say that again, Dalton.
3 cubed.
So this is 3 cubed equals 3 to the y. Now our bases are the same, and y is 3. Good. Let's look at 16. On 16, we know this is equal to y. So here is my b, x, and y. What is the exponential form here? Daniel, what's going to be the exponential form?
12 to the y power. And then
Equals 1. Okay. Now, this one is kind of tricky because I can't make 12 become a base of 1. But if we think about this, If I raise anything to what power am I going to get 1?
0.
0. So in this problem, there's actually not a lot of work to show. Okay? We change it to exponential form, and then we know that the answer is just 0. Okay? All right.
You would change both of them into 0?
Nope, just the y value is 0.
So is
Because
this,
the exponent's
Okay.
saying, you know, if you plug 0 in here for your exponent, 12 to the 0 power is 1. Yep, so we need our y value to be
is
0.
it safe to say that anything, once we convert it to exponential form, if it says equals 1, we can assume the power is 0?
We're not just assuming, we know that to be true. But yes,
Well, that's what
if
I'm
it's equal to
saying.
1, then yes, the exponent should be 0. Okay, let's go down and do number 19 and 20. So let's hop down to number 19, please. So I'm going to set it equal to y. Exponential form is 9 to the y power equals 1 over 81. Okay, so we're trying to solve this. Any ideas what we need to do before we go forward? Someone who I haven't heard from yet today.
Change the 81 to 9 squared.
Okay, but it's 1 over 81, so what do we do with fractions?
Oh, we change it to you minus the 1.
To a negative exponent.
Yeah.
Is that what you're going to say,
Yeah.
Lexi? We're going to change 81, 1 over 81 to be 81 to the negative 1 power. What'd you say? To make it a fraction as well? And that would make it a little bit trickier for us to do that. Remember when we were reviewing yesterday's homework today, anytime we had a fraction, we changed it. Okay? All right, now 81 can become a base of what? Of 9. Okay. Ryan, what are you going to change 81 to, Ryan? 9 squared. And we still have this negative 1 out here. So my bases are the same. I can drop them and I get y equals, I'm going to multiply 2 times negative 1 and get negative 2. Questions about 19? All right, let's try 20. First thing we do is set it equal to y. Then we're going to rewrite it in exponential form. If 64 to the y power equals 4. So we want to change 64 to be a base. Let's see if we can make it a base of 4. Daniel says yes. Daniel, what is it?
4 cubed.
4 to the 3rd power. I still have my y out there. Now that your bases are the same, cancel them. And I have 3y equals what?
0.
What is this exponent up here for this 4?
Oh, 1.
There's a 1 there, right? So I have 3y equal to 1.
Wouldn't that actually be 1/3 after we divide off?
So when we divide by 3, yep, we get y to be 1/3. Okay, questions on that? If you were gone yesterday, this is the part you missed, was changing bases and getting them to be the same. That's what you missed yesterday. Okay? Okay, so some logarithms are not as easy to evaluate as the above and will require the change of base formula. Okay? So if I looked at, let's look at 23 first. Okay? If I were to do 23 like we had just been doing up above, and I set it equal to y, and I take 2 to the y power equals 54. Okay, if I tried this, take your calculator for a minute and see if you can get 2 to the something power to equal 54. See what you can do. Aspen says no. Daniel says no. You're not finding it, right? You go over 54 to 64. Okay? So sometimes there's not going to be a whole number. So of what we've learned now, we would be stuck. All right? So when this happens, when you can't find a base that's common for them, we use this formula called change of base formula that looks like this. Up here in this box, if you have log base b of a, you can change this to be log base 10 of a over log base 10 of b. Why do you think we're using log base 10? Because then we can use our calculator, right?
Which one's the X and which one's the Y number?
What? So here's the thing. Whatever number is, here's the way to remember it. Do you see how B is already low, right? It's the low subscript. So that one's always going to go on the bottom. Okay? B is already low, so it's already going to go to the bottom. And whatever number this is, this A, that's always going to go up to the top. Okay? And then it becomes a division problem. We changed it to a division problem. So if we look at number 23, this 2 is my B, 54 would be my A. So I'm going to write log base 10 of 54 divided by log base 10 of 2. Everyone okay with that? Now, when you're using your calculator, you have to be really careful. All right, so go ahead and type in log in your calculator, and as soon as you hit log, a parenthesis comes up, right? You guys see that? And then you'll type in 54, and then you must close your parentheses after 54. Okay? So log 54 in parentheses, then you're going to hit the divide sign,
Log again.
and then log 2, and close your parenthesis on the 2. And then push enter.
Hello, decimal.
And you're getting, yeah, you should be getting a decimal. So log 54 divided by log 2. I'm getting 5.75. Is that what you guys are getting?
Yeah.
Okay. We like to take it out to 4 decimal places. All right. So on this one, 5.754. But then this is an 8. What's the next number after 8? Another 8. So is this 8 big enough to change this? We've got to talk about rounding here.
Yeah.
It is, right? So this should be 5.749 because we are rounding to 4 decimal places. So this is what our y value is. What I'd like you to do now, in your calculator, take 2 raised to the 5.7549 and see what you come up with. 2 raised to the 5.7549. What number are you getting?
54.00.
One person says 54. Are you guys getting 54.0000? Yep. Now, is there any way you would have come up with 5.7549 on your own? Absolutely not, right? Not even I, who has a degree in math, would have come up with that on my own. That's why this change of base formula is helpful. So that when you can't find what the bases are, you can use this change of base formula, all right? So let's try number 24. If I did 10 to the y power equals 294, there's no way 10 to the whatever power is never going to give me 294, right? So on 24, this is my b value down here. This is my a value. And I can write the change of base formula. You are not allowed to just plug it into your calculator. You need to actually show me that you did this part. Log base 10 of 294 over log base 10 of 10. Interesting. Okay, you use your calculators. Make sure that you use your parentheses.
I forget, do we type in 10?
Nope, you don't have to type in the base at all because your calculator, remember, has already programmed that. And then I want you to round to 4 decimal places.
So we're basically doing a log division by the base and the x.
Sure. Yes. I'm getting 2.4683. Is that what you guys are getting? And if we checked in your calculator, do this. 10 raised to the 2.4683.
293.96.
Yeah, 293.96, and we needed it to be what? 294. So we're pretty darn close, right? We rounded, which is why it's not exact. Okay. All right, so this is how you do change of base. Does anyone have questions on the change of base? Ryan?
How would we apply
Hang on,
this?
Crystal.
I was just wondering, where did the 10 come from the denominator in that one?
On the second one?
Yeah.
So it says my base right here is 10, right? That little one is 10, which is where I got this 10 from. Right? Over here it was 2. It was a 2, and that's how I got the 2 there. Okay? So whatever that low number is what number goes on the bottom.
Oh, thank you.
So, the A and the B in the formula is X and Y.
Yeah, kind of a way to think about it, yeah. All right, so your homework for this lesson is to do page 11 and 12.